Hello everyone, welcome to the Godot Basics Workshop. So today we're going to be going over some of the basics of using Godot Engine. But first off, I want to give a special thanks to the Cal Poly Pomona Digital Humanities Consortium. The DHC at CPP is a collaborative space where students connect technology, creativity, and the humanities. There are several workshops and events hosted by the DHC this semester, including this one. This one was made in collaboration with the DHC. If you'd like to check out some more of their events, you can scan this QR code for their website, which lists all the events that they have this semester. Alright, first off, here's an introduction. So here's our agenda. We're going to be going over what is Godot and how to get started with it. Then we'll be navigating the editor. You'll learn what nodes and scenes are, how to use GScript, which is Godot's main programming language, 2D basics, user interface, 3D basics, and a conclusion. So first off, what even is Godot Engine? Godot Engine is a free and open source game engine that supports 2D and 3D development. It can be pronounced Godot or Godot, either way is fine. And you can export games on several different desktop platforms, such as Windows, Mac, and Linux, as well as mobile platforms like Android and iOS. iOS does require a little bit more work, but it does work. Yeah. So Godot is a pretty new game engine, especially compared to other engines like Unity and Unreal, but it's becoming more widespread, especially among the indie space. So a couple popular games made in Godot are Until Then, Buckshot Roulette, I'm sure this one's pretty popular, Endoparasitic, and Cruelty Squad. Alright, getting started. So there are actually two ways to install Godot Engine. First, you can download it from the website. This has the most up-to-date version just out there, but they do have older versions as well, and I believe the build for using C#, but we'll get to that later. And you can also install it on Steam, so basically like download it like if it was a game. I recommend installing it through Steam actually, because that way it'll like automatically update. Otherwise, if you download just the .exe, you'll need to like download the most current one every time there is one. So I recommend using Steam. These slides are actually old. It's actually the most current up-to-date one is 4.5. Unless you have a specific reason to, I recommend using the most up-to-date version, just because it has the most features and is kind of more compatible with like modern like engines, or sorry, not modern engines, modern like rendering and stuff. So yeah. Alright, so you might be thinking, okay, cool, now that I've downloaded Godot, I can start making a game right away, right? Hold on. So if I may get on my soapbox for a second, a lot of Godot Engine tutorials kind of throw developers into making a game right away. This isn't necessarily wrong, it just teaches game devs how to make one game. So once they want to make something else, something different from what they learned in their tutorials, they don't really know. So this workshop is going to teach you how to navigate Godot's user interface, syntax, development principles, independent of making a specific type of game. So then that way you'll have the tools and the knowledge to develop any game, including your own. Alright, first off, let's learn how to navigate the editor. So when navigating, the first thing you would see when opening Godot is the project manager. So here you can create a new project, import existing projects, which will have a file called project.godot. If you haven't made a game yet, you don't need to worry about this, but it's good to know. And you can also view the asset library from here. We'll get into what that is in a little bit. So to create a new project, so this is the screen you would see when you open up Godot. All you have to do is click create here or create here. We'll click create. We can name it whatever we want, so we'll just name it Godot Workshop. You can choose your file path right here. Your renderer, this isn't super important, but you can change this also in the engine itself. And here is the version control metadata. So if you're going to be working with a team and using GitHub, I recommend leaving this as Git, because then that way it configures the git ignore to ignore certain files in Godot. That just makes it so you have a little bit less extra files, like import files. And then here's this checkbox for edit now. You could just click create and it'll open it. It'll open a blank project. Alright, so now we have our new project. Alright, so this is kind of the general overview of what Godot's editor looks like. It has a few different panels and we'll go over each of them. So first off is the taskbar. This is on the top of the screen. So each little window has different options. So the scene option has actions like adding new scenes, opening scenes, saving, etc. So as you can see, I'll click scene. There we go. We have like new scene, new inherited scene, open scene, etc. And also quit. You can quit from here. Next, we have the project tab. This includes project settings, which we'll get into in a minute, exporting, project reloading, and quitting to the project list. So if I click project settings, version control. I haven't used this too much, but it could be useful. Exporting, reloading, quitting, stuff like that. Debug. So this has options for debug settings like collision and path visibility. This is pretty useful if you're like programming like navigation or like working on collision. Like if something's going wrong, you can kind of see if your collision shapes look correct. We'll get into what those are a little bit later. Editor, this includes like editor settings and also export settings, especially for like Windows, along with like layout settings and command palette. Those aren't super important right now, but good to know. The help tab has some quick links to the Godot documentation, the forums, bug reporting, and more. These are quick links to all the workspaces. So these include the 2D, 3D viewports, along with the script editor, the game viewer, and the asset library. And then the playtest buttons. So these are for running the game. So this is like for running like the main scene, the pausing and stopping. This little like movie icon is for playing the specific scene you're currently at. So it'll run independently of everything else. Yeah. All right. So the viewport. The viewport is like the main like workspace of your game. So it's where you're going to edit your game's world. It has settings for transforming objects and adjusting like the camera view. You can also have multiple viewports open with a different scene on each one. And you can do that by pressing the plus button. So as we see here, we have one current scene open. And we can click the plus button to open more. Though I do think you need to have the scene saved. So let me check that. Here, let me try it through here. Okay, that's weird. Maybe I need to... Yeah, there we go. Alright, so then, yeah, now we can add new scenes. You just gotta make sure that each one is saved before you add a new one. Alright, here is the taskbar. So it has a couple of tools for manipulating scenes. Each tool has its own hotkey, but you can also press it from the toolbar itself. What the specific tools are will change depending if you're on 2D or 3D. But generally, for both, select mode, which is Q, allows for selecting different nodes or objects in the viewport. Move mode allows you to like move or translate the node that you have selected. Rotate mode allows you to rotate. Scale mode, scale. And then everything else, well, mostly everything else is kind of related to like snapping. So this will like change, when you're moving like objects, it'll like change how they snap, so like different, maybe like through grids or to the nearest object. It'll kind of depend. I recommend checking the documentation for this because there is a lot of settings. All right, the 2D workspace. So the 2D workspace allows you to edit a 2D scene. It is used for editing both like 2D games as well as editing user interfaces. The 3D scene is for 3D games. It also has specialized settings for lighting and meshes. The game workspace is where your project will appear when you're running it through the editor. You can actually pause and play your game and adjust it in real time. The script editor is a complete code editor with a debugger, auto-completion, and built-in code reference. So Godot is not like Unity or Unreal where you need to have a separate IDE when editing code. So you don't necessarily need like VS Code or Visual Studio. Writing your script is done just straight up in the editor. So that's pretty useful. The asset library is a library full of free and open source add-ons, scripts, and assets to use in your projects. So these are kind of like tools made by the community for specific things, like maybe like dialogue systems or terrain. Yeah, you could also find these online as well. All right, so let's move on. The file system doc. So the file system doc, which is at the bottom left, allows you to access the files of your projects like folders, assets, scripts, scenes, etc. You can also search for and filter files here, just for some added organization. All right, the scene doc. So the scene doc lists the active scenes nodes in a tree structure. Here you can add new nodes to the tree. So this is kind of like the, what's the word? The structure of your scene. We'll kind of get into more of what this means in the next section. Along with this, it also has the import tab, which, here, let me show you. So here, if you like select like a image, it has different settings for how it's imported into the editor. This is both for images and 3D models as well. All right. Next is the inspector doc. So the inspector allows you to edit the properties of selected node. So if you have an object like a 3D node, you can edit like values like the transform, like the position, rotation, scale, etc. Along with this, in the same tab is the node tab. So this includes different settings for signals and groups. We'll get into these a little later, but these are pretty important. I've never used a history tab, but it could be useful. I don't know. Try it out. All right. Last is the bottom panel. So the bottom panel is kind of the miscellaneous tab in Godot. So it has several tabs for special windows like printing and error output. It has a pretty good debugger. Audio settings, the animation player, which we'll get into later, shader code editor, and also settings for tile maps. So if we can open it up, this is where if you have anything in your scripts that print text, it'll show here. It also shows errors and warnings here. The debugger, this is a lot. There's a lot to cover, but it is quite useful if you're having any issues in your game. Audio, this is for like making like separate audio like buses. We won't go over that, but it's good to know. The animation player, I will explain this later, but this is for animating properties. And the shader editor, nothing here, but this is where you can write shader code for like 3D objects. All right. Next is the project settings. So this is accessed through scene on the taskbar. So it kind of has general settings for your project like resolution, rendering, physics config, input mapping, global variables, plugins, and a lot more. So all you have to do is click scene up here and then, or wait, scene. Sorry, no, it's project settings. My bad. That's a mistake. Yeah, so project settings. Apologies. Yeah, so there's a lot of settings for like config, running, window, like your resolution, rendering, and then on the other, on the other tabs, we have input mapping. So it's like all of the what's the word? Like input actions in your game. Localization. I've never used this, but it's for localizing games in different languages easily. Global variables. Plugins, so they're just another word for add-ons. Here's where you like enable them. And import defaults, this is for like the default for importing different file types. So I've kind of talked about a little bit about nodes and scenes, so I'm going to explain what those are. So nodes are Godot's equivalent to like objects or components. I believe components is what they're called in Unity. There are many kinds of nodes that can do different things, like display images, play sounds, be a camera, be a player, etc. They all share the following characteristics. They all have a name. They all have properties that you can edit. They receive callbacks to update every frame, so they just can update every frame. You can extend them with new properties and functions that you can write yourself, and you can add them to another node as a child. So when you add nodes to other nodes as a child, like as a tree structure, this will make a scene. So once saved, scenes kind of work like new node types in the editor. So you can add them as children of existing nodes in other scenes. So scenes are used to make larger parts of your game, like players, levels, stuff like that. All right, so we're going to see how we can make a scene. So you want to make a new project, and in an empty scene, the scene doc on the left shows you several options to add a node, specifically a root node. So this is like the very top of the tree structure in a scene. It will not be a child of anything, but it will be like what has all the other children. So to do that, we're going to go into an empty scene. So let's go into this one. And then we're going to want to choose a type of root node. So we have a couple default options right here for like 2D scenes, 3D scenes, user interface. For now, we'll use label to test that. All right, so now we have a scene with a label node as a root node. So a label node is just text in UI. All right, so as you just saw, we kind of added a new node using the create new node dialog. It'll show a list of all the nodes and you can search for it. And you want to click create at the top, at the bottom of the window. All right, so now you have it, cool. So the node will appear in the scene doc and its properties will appear in the inspector doc on the right. So let's mess with that. Let's edit its properties. So we can change the text to something like hello world by going to the inspector doc and clicking inside the field below the text property and typing hello world. So let's do that. So we're going to type hello world in this field that says text. And you can see it edits right there. Don't need the parentheses, or the quotation marks, but it's fine. And there you go. Now you have hello world in your scene. You can also move around your label node by selecting the move tool in the toolbar and just dragging it anywhere. So as you can see, we can click the move tool right here and move these little handles and drag it to like the middle so we can actually see it. All right, so now we're going to run the scene. So as I said before, you can run a scene by clicking the top right play button. So how Godot works is that there is something called a main scene. So this is essentially the first scene in your project that runs. A pop-up will tell you to save the scene if it hasn't already been, and then you can set it to main as well. So you could also edit this in the project settings later. So let's do that. All right, so we have our main scene here. It's unsaved. We want to save that. So we can press plus here, and then we can click select current. And then we're going to save our scene as like, we can change it to like main or something. Save it. And then let our scene run. And there we go. Now we have our scene. So as you can see, what we have in our editor will appear in our like played game. All right. As you can see, this is what we have. So now you've made your first scene. All right. Once you've saved a scene, you can also kind of treat it as a blueprint so you can reproduce it in many scenes, in other scenes as many times as you'd like. This is usually referred to as instancing. So you can do this by dragging scenes from your file manager into the current scene you want to add them to. So this is useful for like having objects that kind of repeat themselves a lot. Like maybe like a tree in a town that you want to use several times, or like an enemy. All right, now we're going to go into the kind of what makes your game work, which is coding, GScript. So GScript is the main programming language used in Godot. It's good for beginners because it has really simple syntax and it's really easy to kind of like iterate on your ideas. It's pretty similar to Python. So it's based on the object-oriented programming paradigm, which is kind of, in general, the concept of using objects and classes to kind of organize your game structure. It's dynamically typed, which means that you don't need to like statically type what kind of object a variable is. You can just do var name, then the value. No semicolons. So every line of text can just end. You don't need a semicolon like you do in C++ or Java. But Godot Engine also does support C# and C++ via GD extension. This requires a little bit more work. You kind of need a special build, but if you want to do that, you totally can. All right, so how do you add a script? First, you're going to go to the node that you want to add a script to, right-click it, and then click Add a Script. So let's do that. So let's try it with our label right here. So we're going to go to Label. Then we can either click right here, this little script button, or we can right-click and click Attach Script. Then here, here's like the little window that pops up. You can kind of name it, so we can call it Label. You can also change the template. So Godot has a couple of templates that, what's the word? Maybe it's not called label. Let's call it text. There. Okay. Yeah, so you can have different templates. This will kind of change depending on what type of node you're making a script on. But if we want it blank, we just click Object Empty. Then click Create. Cool. All right. Yeah, we just saw this. So you can select the script's language and the file path with some other options and then click Create. All right, so we're going to kind of go over how GDScript works and its syntax. So the script workspace should appear, and you should see the following line of code. This here, it says extends node, but depending on what node you make the script on, it'll change. So on ours, it said extends label, as you can see. So every GDScript file is implicitly a class, and the extends keyword defines what class it is. So since we made the script on a label, it'll make a script with a label class. So this kind of defines what built-in variables and functions that you can use. So for something like label, it might be like change text, or I can't remember off the top of my head, but if you check the documentation, you can see what variables and functions are built in for every class. Extends node is like the barest bones, barest bones object class. Yeah. But this will depend. Alright, so variables. So data like health, speed, and objects can be held in variables. As stated, since GDScript is dynamically typed, you don't necessarily have to statically type a variable like you would in C++ or Java. But you can. You can do it by doing like var, the variable name, and then with a colon, put its type, and then it equals its value. This is helpful because it gives you better code auto-completion. But it's not necessary. You can also create variables that can actually be edited directly from a node's properties using the @export keyword. So that goes before var. And these also do need to be statically typed. These are pretty helpful for like creating objects that might have values that will change from object to object, and you want to be able to edit them in the editor itself. So this is good for like stuff like if you want to be able to like adjust the speed of a character quickly, you can do that by doing @export speed. So if you want to change that value, you can just do it in the editor rather than having to go like into the script and do it. It's not like a huge thing, it's kind of just quality of life. Alright, variables can also be used to contain references to nodes within a scene. So this requires special syntax because it's like you're putting an object into a variable. So before the variable declaration, the keyword @onReady needs to be added before var. This makes sure that the variable only gets set after the node that you want to load into it is loaded and ready. So you don't want to try and add something that isn't ready into a variable because then it will just be null. The object also is supposed to have a $sign in the beginning of the node path. This just designates that it is a node path, and the game will look for that node within a scene tree. So right here you can see we have @onReady. That's our keyword to make sure to only load this when this variable is ready. Var, sprite, our type. You don't necessarily have to do this, but you can. And then you have equals $sign sprite2d. If you have like an actual node tree, it'll like be like slashes, kind of like a file path in your computer. All right. Code that is used frequently can be put into functions. So GDScript functions are pretty similar to Python functions. They use colons instead of braces, and they use indentation to nest code. So these are pretty useful for like things that will be repeated, or maybe like things that if you're kind of going with an object-oriented structure, which you should, things that will like change depending on each object, but you'll still want the same function to be run. GDScript also has a couple of built-in functions that have like important uses. So _ready will run whenever a node enters the screen and is ready, when a node enters the scene and is ready to use. _process with the, a parameter of delta, and _physics process with a parameter of delta. These both run every frame. Delta is kind of just like a variable that is kind of used to equalize like time differences. I'd look into like what that means. I can't really explain it right now. But those run every frame. Those are good for like movement, just stuff like that. And _input and _unhandled input. These run every time there is an input. So this can be like any kind of input, like keyboard presses, mouse movements, stuff like that. All right, loops and if statements. So GDScript has loops and if statements like any other programming language. If statements use a colon and indentation instead of braces, like functions, like Python as well. The if statement's expression also does not need to be in parentheses. Unlike a lot of programming languages, it can just kind of be there and then have the colon. And then loops also work a bit differently. They use a built-in function called range. I believe Python does this too. The number of loops is the parameter of each function. And it's not on the slides here, but you can also iterate through arrays like this. So you will be like for I in, and then your array. I don't go into arrays here, but it's pretty similar to like arrays in most programming languages. Lastly, Godot. Wait, no, sorry. Lastly, input. Of course it's Godot. So input. Godot has some built-in input maps, as we saw when we looked at project settings. So let me see here. Yeah, so there's a lot of built-in input mapping. So this is kind of for stuff like accepting or like the keyboard arrows. But you can actually make your own. So let me close those out. So to do that, let's do something like we maybe want to add like an interact action. So we can type in the name of it, interact. And then, so now we have our action, but it doesn't really have any like bindings tied to it. So we can press the plus here, click add event, press something like E, but we can also do like different types or like mouse presses, but let's stick with E. Then we'll press OK. And there we go. Now we have another, a new input. We could also add more mappings to this. Maybe you also want like right click to also be interact. We can do that. Press OK. So now whenever we ask for this in code, either of these will initiate like the interact. So to do that in code, we want to add some special functions. These are in the input class. So we can do input._ is action just pressed. So this checks if what's the word? If our input was just pressed. So this means it's like only pressed once. If you want to check if it's being held down, we can do is action pressed. So no just. So you want to put your the name of the action you just made in these parentheses. So, and this is usually done in like process. So like anytime this action is done, it will check if it has been done and then run some code. So signals. Signals are messages that nodes emit when something specific happens to them. So something like a button being pressed. Other nodes can connect to that signal and call a function when the event occurs. Signals are very, very helpful. They're very helpful for getting two nodes to communicate. But they do have some idiosyncrasies that can be easy to trip up. So for example, let's say we have an emitter node and we have a receiver node. So the emitter node emits a signal, but the receiver wasn't necessarily listening for that. It doesn't really make much sense for every single thing to be constantly listening for emissions, because that is not very optimal. So the receiver has no idea that this was emitted. So what we need to do is we need signals to be connected. So there are two ways to connect signals. So first you can do it through the editor. So let me demonstrate. So let me do something like, let me add a button. All right. So we want this button to, we want the code of the label to do something if this button was pressed. So we can go to node. So this is where you would find all of the built-in signals for an object. Then we click pressed, want to right click it, and then click connect. Then we want to select the node that has the script where we want something to execute. And then it'll automatically create a method. It has a default name, but we can change this. So maybe we want to do like just button one press. Maybe we'll have multiple buttons. And then we'll click connect. And then there we go. So whenever this button is pressed, so in the editor, something will run. Something like a function in the label node. So maybe we can do like print press. So we save that, click label. This is a little bit small, might be hard to press, so let me make it bigger real quick. One moment. It's gonna be like 50, 50. There we go. Okay, so we'll click plus. So if we click that, we can see that our code was executed. All right, as you can see here, this is how it works. We have the little green arrow on the side too. We can also do it through code. So signals can be connected through the editor, through the inspector doc like we just saw, or you can do it through code. So to connect a signal, you would do the name of the receiver as like a class name, dot the name of the signal, so like the name, the user defined signal here. You could also do built-in functions this way. Dot connect, and then as a parameter, it would be the name of the function that you want to run whenever that signal is emitted. Signals can be emitted on certain built-in actions, like we said. You could check the documentation for the names of those, or you can make your own. And to emit user-made signals, you would use the name of the signal dot emit, and then username signals can have parameters as well. So now that our signal is connected, the receiver is actually listening for that emission now. So now when the signal is emitted, since they're connected, the receiver will actually like hear it and it'll execute the given function. All right, next up, groups. Groups are pretty simple. They're just a way to organize nodes that are kind of treated as a group, such as enemies, coins, etc. And you can use groups to get a list of nodes, of all nodes in a group, or call a method on all these nodes, or send a notification for all the nodes in a group. As stated, they're kind of good for like enemies and like objects that maybe you might want to all hear or do the same thing. Yeah, as you can see, so this is how you make a scene. Actually, let me do that. So to make a group, you click, so here in the node tab, you want to click this separate tab called groups. You're going to click this plus, so we can call it like enemies, and then here is this little like toggle for making it global. So this will kind of this will change like who has access to this group. So we leave this off, the group will only be accessible from within this scene. But if we change it to global, any scene can access this group. Then we'll click OK. And you can see here we have the listing of all groups that a given node is a part of, and we can also turn it on and off. Next is singletons. So singletons are Godot's equivalent to global scripts. They allow any node to access a script's variables or functions. And these scripts persist through scene changes as well, so they will never be destroyed. They're only destroyed when the game is closed. So autoloads can be made in project settings by selecting any script you want in the file system and then giving it a name to be used as its reference. So if we see here, go to project settings, and let's say we want our text scene to be global for whatever reason. Typically you want to do this with like scenes that will actually need to be accessed by anything. They're typically used sometimes for like making signal buses. That's for like making it easier to do signals. I recommend looking into that. But for now, we'll just do our text scene. So we go into the file editor, click text.gd, open, and then we can change the name for what we'll use as the reference whenever we want to reference our global nodes. We can just call it global variables or something. Click add, and then there you go. We can turn it on and off as well. All right, resources. So resources are kind of data containers in Godot. Anything Godot saves or loads from the disk is a resource. So this can include a lot of things like textures, meshes, animations, fonts, scripts, and a lot more. They can also export properties. These can be integers, strings, vector2s, etc. So just remember that anything that you load from a disk will be treated as a resource. You can also look into like all the types of different resources. Sometimes it can be a little tricky with images because there's like several different types of image resources. So I recommend doing some research on that. All right, project organization. So organizing your project's file system is pretty key to working efficiently. You can make dedicated folders for different aspects of your game. Typically what's recommended is doing separate folders for scenes, scripts, assets, and then in your assets folder you want to like break it up even more. So maybe you want to have like textures, audios, fonts, etc. This isn't hard and fast. Exact organization structure will depend on what works best for your project, but it is still a good idea to be organized in some kind of way, especially if you're working with like another group of people. All right, so that's it for GScript. So now we're going to move on to some kind of basic 2D principles. All right, so Node2D is a base class for all non-UI related 2D nodes. All 2D nodes are children of Node2D. So Node2D has a position, rotation, scale, and skew. So since every 2D node is a child of this 2D if every 2D node is a child of node 2D, all nodes will have these parameters, will have these properties. So if it actually, when you edit the position of a node 2D, you're kind of editing the node 2D within that node itself. So just know that if a node is blue, it is derived from node 2D. It'll typically have 2D at the end of its name, and it will always have these values. Alright, so one important node 2D is the character body 2D. So this is the main node type used for programming 2D player characters. It allows for movement to be user controlled. They're not affected by physics at all, but they do affect other physics bodies in their path. So this is good for player characters because you want the physics to be controlled by the player, but if you have boxes, you also want the player to be able to interact with those as well. Alright, you might have seen that it had a little warning symbol next to it, and that's because character body requires a collision shape, which is a separate type of node 2D, in order to properly interact with the world. So the collision shape 2D node is a collision object. It defines a primitive shape, like a square, circle, capsule, etc. And this shape defines where collision gets detected. So let's see, let's say we want to make one, so let's close that. Click plus, add a new 2D scene, or actually no. If you make a mistake like that, you can click here, you can right click and click change type, which allows you to change a node's type. We want to do character body 2D instead. So let's rename it to player. And then as a child of it, we want to press plus, go type in collision shape 2D, enter. And then in our inspector tab, we can go to this right here where it says shape. We want to add let's say capsule shape 2D. We're going to press more. We get a little closer and we can edit the shape of this. So we could make it a little tall, making it like a circle, but let's keep it as it was. All right. The camera 2D node also determines what part of the 2D screen will be visible. So for something like a 2D character, we can make the camera 2D node a child of the player, which will always make it follow the player without any additional code. So if we do that here, we can click player once again, add child node, camera 2D, and there we go. So now if we move around as this player, the camera will always follow us without any additional code. Since it's just a child, it'll inherit its position. So sprite nodes are used for adding a texture connected to the player. A sprite node allows you to add sprite sheets to add animations. So in the properties, you're going to want to load the texture, and then you're going to set the amount of rows and columns it has as H frames and V frames. So I don't have it right now, but if we added a texture, let's say we want to add just the icon, we can click the animation tab right here, and we can set the amount of frames that it had. So let's say we have a sprite sheet with 5 columns and 3 rows. Oh, not 26. There we go, 3. So now if we had the sprite sheet, it would be able to chop it up into the correct amount of frames. So if we played it as an animation, it would play it frame by frame, since it's chopped up in the correct way. I wish I could show you, but I forgot the picture, and it's on my laptop. Oopsie. All right, and then you can use the animation player to animate these properties. So you can use it to animate a sprite node by setting keyframes for the starting and ending frames of animation. You want to make sure your sprite is looping if it needs to. So to test that, we'll go into our player, and then we're going to add a animation player node. We're going to click here where it says animation. We're going to click new, and then we're going to name it. So we can call it idle or something. This isn't an actual player character, but it'll do. So we're going to zoom a little bit quick. So we want to, let's say we have a idle animation between frames 0 to 5, 0 to 4, that makes more sense. So we're going to go here, we're going to check our frame right here. So this will change what the current frame would be in our sprite sheet. Then we're going to click this little key icon, key plus icon, and this will add a keyframe to our animation. So we're just going to click create. So as you can see here, we have the first frame of our animation. And to kind of fill in the rest of the frames between 0 and 5, what we're going to do is Let's see, how zoomed in are we? Oh, super zoomed out for some reason. So let's say our animation is going to last 1 second. We're going to want to go to our last frame in the animation. So let's say it's 4. And then we're going to click plus again. And there we go. So if we play it, it'll... Okay. Am I misremembering? Does it have to be? Okay, I guess you have to add every frame in between. My bad. Alright. So that's a little bit annoying. So let's change that to 2 just to make this quicker. So we're going to change, let's say our last frame is 2. And then let's say at 0.5 seconds. Oh, sorry, not there. Here, down here. That's how you change the current frame. We're going to add our frame in between. So let's say frame 1. We're going to add another keyframe. So now if we play, it goes through the animation. So if you had a kind of a longer animation, you would have to, I believe there's an easier way to do it than doing it every single frame, but I'd recommend looking into that because there's also other different types of, different types of nodes that allow you to add animations a little bit more quickly and easily, but this is kind of a quick and dirty way to add sprite animations. Oh yeah, and if you want it to loop, I forgot to mention, you want to click this little arrow thing right here. So if you play it, it'll play continuously. So this is good for like idles and running. All right. So to program character movement, you're going to require vector2 variables. So these are kind of XY values, values with 2 different individual values. Said values a lot there. So that is usually like an XY. So it's good for like 2D since it's, you have an x-axis and a y-axis. So you want to create a variable called an input vector. So this gets a numerical value representing the input strength from each direction. And it'll set the built-in variable. The variable velocity is built into character body 2D. It'll set velocity to that value multiplied by a user-defined speed value. So this will kind of change how fast the character will move. So as you can see here, we have input vector.x, and then these, as I said, will kind of get the strength of each input. So if let's say you have like, you only want to move right, so it will be like the strength of the right value minus left, but since you're only moving right, it'll just be 0, so you'll just move right. And then you will multiply by speed, and then you want to use the move and slide function. So this is a pretty important function in the character body 2D node. So this will kind of get all of this information and cause the player to move. Then this is done in the physics process function, so this gets called once every single frame. Alright, and then to play animations in this code, we want to reference the input vector. So we can usually use the input vector kind of to determine what direction the player is facing. So let's say our input vector is vector2, 0, 1. Well, since this is the x and this is the y, we can assume that if we have 1, that means we are moving, I believe, downwards. Yeah, that means we're moving downwards. So we can kind of assume that we're moving downwards so we can play our run front. Since our player is facing the camera, we want to run forwards. And then, or if we want to do like, if we want to move, I believe this is left. No, this is right. Yeah, if we want to move right, then our x will be 1, and then we'll play our run. And if you want, you can also make, if your sprite is going to be symmetrical, you can make actually only one side animation. So not left and right, just a side, and then you can change the sprite's flip H property, true and false. So that's just kind of an easier way to make a left and right animation, so you only need 3 animations instead of 2. And then if we want to add an idle still animation, we can check our vector2 is 0, 0. So we can automatically assume that if our input vector is 0, 0, we're not moving, so we can just play idle. Yeah. Alright. One quick thing about viewport settings. So when working on a 2D game, it's important to have the correct viewport settings. This will kind of change how your game looks and how its resolution is. So some recommended settings are send your stretch mode to viewport and send your stretch aspect to keep. These will kind of just make sure that your pixel art looks correct and not like blurry. And then you also can set your viewport width and height. So Godot has kind of 2 separate viewport width and height. So the actual one is just viewport width and height. You can make, if you're working on a pixel game, you want to make this pretty small so like your pixels render correctly. But by using the window width override, you can kind of get this small game and blow it up to be the full screen. This is really mostly important for like 2D pixel games, but it's important to know. And then here is the result from last year's Godot workshop. So, yeah, this is kind of everything put together. So you have your character movement, you have your camera connected to the player, you have your sprite animations, and then you also have some like tile maps. We won't go over that, but that's just how you can tell that your player is moving. Yeah, so this is kind of a very basic bare bones 2D movement system. All right, next up is user interface. Let's say you want to add to some visual communication of things like health in your game. So Godot calls the UI related nodes control nodes. So these feature a bounding rectangle that defines its extent, an anchor position that defines the relative position in contact with the rest of the screen, and offsets relative to that anchor. This might not mean much, but I'll explain it in a minute. But all you need to know they are very useful for creating flexible UI that will adapt to different screen sizes and resolutions. And control nodes are typically colored green. So what are anchors? Anchors are pretty important. They define a control node's position and size relative to its parent control or current viewport. So this essentially means that it will adjust the node's size depending on the size and resolution of the full screen. It's kind of like its position in contact with everything else. So this just makes sure that everything will be sized correctly as you want, no matter what your resolution is. All right. So containers are a type of control node. They define how the control nodes that they have as children are arranged on the screen, and that there are several types. We'll get into those in a second, but they have a couple of settings to take note of. So fill will make all of the elements it has as children fill the designated area. Expand attempts to use as much space as possible within the parent container. And shrink pushes all elements to the designated size. I will demonstrate that in a second. But there are several types. So there is the HBox container, which arranges children in a row horizontally. The VBox container, which arranges them in a column vertically. A grid container, which will arrange them in an n-by-n grid, so the n will be whatever size you want. The margin container has adjustable top, left, bottom, and right margins around children. These are pretty useful for making like visually appealing UI. And the scroll container allows the user to scroll to see non-visible elements, but this does require a container like a VBox as a child. So let me demonstrate. So let's go to, let's make a new scene actually. So we're going to go to user interface. So we have our base control node. So let's say we want a HBox container. So we're going to make one of those, and these are kind of useless like without children. So what we need to do is we're going to click add node, and we'll put like, I don't know, like a label or something. And we'll just kind of put a Q smash in there. Let's say we want to have multiple of these in a row. So we'll just copy and paste these. And as you can see, it automatically adds them as like one single row. Maybe if we change this to like VBox container, it'll change to columns. So this is pretty neat. You can kind of adjust how these are arranged by, where are they? You can change the alignment, so you can change it to like center and end. I'm not sure why it's not working right now, but whatever. But the important thing is where are you? Where is it? Oh, here it is. Is it? Yes, it is. Yeah, so these settings kind of change like how a control node will fill the screen. So it's not, yeah. Can't really demonstrate it right now. I don't really have the scene too, but just know that those will kind of change. So as you can see, the kind of bounding box, it will change how much of the screen that will fill. I would recommend looking into that, especially if you're going to make a very UI focused game. All right, labels. We kind of went over that earlier, but labels are simply used for displaying text in UI. The label node is just used for like plain text, but you can't really do a whole lot with it. The rich text label node is a kind of expanded version of the label node. It supports bold text, italic text, as well as BB code effects. So this is kind of like a markdown type kind of language. Not exactly. But it supports different things like color, animations, and a lot more. So as you can see, we have like different color text. You can also like put tags separately so it doesn't have to affect the entire text. And also animations and rainbow. Cool. Next we have buttons. Kind of looked at them earlier when we were talking about signals, but they emit a signal when they're pressed, and they can be connected to a function for any behavior that you need. They can also have different appearances for when they are pressed, hovered over on, focused, and more. There's also the texture button, which allows you to use images and textures as buttons themselves, and also have different textures for the different states of the button. Okay. Themes. So a theme is a type of resource for styling control nodes. While you can use something called a local theme override to kind of change how different UI elements will look, theme resources allow you to store and apply these same settings over all controls sharing the same type. So all buttons, all labels, etc. These are pretty useful if you're going to have a lot of UI that will like repeat itself. So I'd recommend looking into this again if you're making games with a lot of UI. Kind of just saves you time since the node, the theme override settings will be automatically done. You don't need to set it for each individual type. Sorry, each individual node. All right, that's it for UI. There's a lot for UI. I'd recommend doing a little bit more research. A lot more than I can cover reasonably within this workshop. But yeah, lastly we have 3D basics. So it's not stated here, but 3D nodes work similar to 2D nodes where they have a base class of node 3D, which is typically red, and these node 3Ds will have those like position and skew values. We'll get into that in a little bit. But first off, let's learn how to navigate the 3D workspace. So it kind of works similar to like flying or no clip in a lot of games. So moving around with WASD will kind of fly you around the 3D space. Scrolling with the scroll wheel will zoom you in and out. Moving the mouse while holding down right mouse button or scroll wheel will kind of like pivot the view. It kind of changes whether like which like other button you're holding it down. And holding shift along with the middle mouse will kind of pan the view. So let me demonstrate that. So let me go back to our test scene. So if we want to kind of fly around, we'll hold down our right mouse button and just move WASD, click fly around. If we want to zoom, we'll just move our scroll wheel in and out. If we want to kind of pivot, we will hold our, so if we hold our right mouse down, it'll pivot around that central point, typically the selected node. We could also do the other way with our holding down our scroll wheel. And then if we want to pan, we'll hold shift and move our scroll wheel. Or hold down our scroll wheel, sorry, and move our mouse. So there we go. So 3D coordinate system. Godot's 3D coordinate system is kind of different to other 3D programs you might be familiar with, like Blender. Here's a helpful infographic which kind of shows like the different coordinate systems of 3D software and some games. So Godot uses a Y-up right-handed coordinate system. So this means that the Y-axis is the vertical axis. So the Y-axis will always be pointing up, and the Z-axis is used as a pointing towards direction. So this is pretty important to know, especially when you're like importing models from Blender to Godot, since they're both different. That could potentially cause some issues, but if you have the correct import settings, you should be fine. There are two key data types to understand when you're working in 3D. These are the transform 3D and vector 3. So vector 3 is a three-dimensional vector. It has, like vector 2D, it has like a group of values, this time it's 3. So it's X, Y, and Z. It's typically used for stuff like velocities, positions, and directions. Transform 3D is a more comprehensive type that not only it just covers a object's position, it also has its rotation and scale. And each of these components is its own separate vector 3. So its position will have 3 values, X, Y, Z. Its rotation will have 3 different values, X, Y, Z. And its scale will have 3 different values, X, Y, Z. Yeah, so that's kind of, and each node 3D will have a transform 3D, which defines its own position, rotation, and scale. So it's similar to node 2D in the sense that every 3D node has these 3 values. So like in 2D, you can rotate move and scale objects in 3D mode, and this is done using a manipulator gizmo, which has different control handles for each action. So if we want to, if we want to move an object, like we want to translate it on one axis, we can use these arrows. So this is like X, Y, Z. Then these little squares will actually move 2 axes independently. So let's see, like, so this one will move, I believe is it X and Y? I believe it's X and Y. No, sorry, it's X and Z. So they will move X and Z without the Y axis. So this is good for like if you want to like move stuff across a plane, but you don't want it to move up, you can use this one. To rotate, you use these little like round handles. So you can't, here, let me actually, oopsie. Let me change this to a mesh instance. Nope, not that. You want it to be a mesh instance 3D. There we go. I'll cover this in a second, but let's change it to like a cube. Where's the cube? There we go. So we change it to a cube. We can see we're rotating it on all axes. And then finally to scale, it's not default, but if we press the little, if we would change our not our viewport, our toolbar to scale mode, these little handles with these little cubes on the end will allow you to scale on different axes. An object will have separate transforms for its local and global space. So global transform is an object's transform relative to the world origin. So the world origin will be like a point in the world, like the center 0, 0. And global transform will return an object's position relative to that point. On the other hand, transform on its own is not called local, it is called transform. This will have an object's local transform, so it'll reference its position based on its middle point. So you can easily get an object's global or local position by using the global transform.origin or the transform.origin property. So if I want to demonstrate this, why does this have an error? Oh, yeah, anyway, okay. Well, I'm gonna move it anyway. So let me move that a little bit. So if we add a script, we'll just call it test.gd. Get rid of that. So let's say we want to, let's demonstrate the difference between local and global transform. So we're going to print our global transform.origin. So remember that this is a position relative to the world origin. And we're going to click print transform.origin. All right, so we're gonna run this scene on its own. Okay. Okay. So my point does not stand because actually in the context of this scene, they are the same. That is my bad. So actually what we should do here, let's change our approach a little. Let me add a child instead. Mesh instance. So we're gonna call this test. Then we're going to go to, let's make it a variable. So on ready var test equals test. Yeah. Okay, so instead we're going to do our tests variables. So let's set this back to its original values. So let me see, transform. Okay, and then we're going to actually move test instead. So let's make this a cylinder instead. We're going to move it around a little. So that's over there now. So now we're going to run it. Not you. Oopsie. No, sorry. You want to run this scene independently. Sure, we'll save that. Save that too. Where are you? Where is this? No, don't run that scene. Run this scene. Okay. Well, as you can see. Huh. Okay. Yeah. Well, this will kind of, I think it changes more in a like active game. This is kind of just like a independent scene. But don't worry if this trips you up. It's a little bit confusing. It's a little bit hard to understand. Just know that typically an object's global transform and a transform will be different. It just depends on the context of your scene. So just keep this in mind. Okay. As you saw earlier, you can quickly create primitive mesh shapes using the mesh instance 3D node. So this is pretty helpful for like blocking out levels or giving objects like the player a visual representation for debugging. You can create a number of different like default shapes like cubes, cylinders, planes, etc. There's also something called the CSG node, which I've heard is a little bit better for blocking out levels since it kind of gives like default collision. And they're a little bit easier to like scale, so I'd recommend looking into those for like level blockouts. And then you can also import models made in Blender or other 3D software into Godot as well. Godot supports like imported armatures and animations. It also supports a number of different formats, but kind of to varying degrees. So typically the one you want to use is GLTF 2.0. This one is usually pretty seamless. It supports textures, animations, armatures. So yeah, I'd recommend using this one. Recently, Godot also added .blend support, so you can just get your blend file where you have your 3D model and just put it into Godot directly. I've never used this too much, so I can't really say how good it is, but I would look into it. Godot also supports .dae or Collada and .obj or Wavefront 3D models. I'd advise using against these since they don't, well, by the nature of the format themselves, they don't support armatures and animations, but I've had issues with them in the past, so I would advise against these. Godot also supports .fbx, though sometimes a little bit weirdly. Believe you need to like install an add-on for it. You might not need to anymore, but FBX is good if you're especially using like Mixamo animations, since those are FBX by default. So just know that it does support those. But yeah, typically if you would ask me what to use, I would say just always stick with GLTF because it'll give you the least issues. All right, and that is it. So today we went over a whole lot. We went over navigating Godot's workspace, kind of the basics of its programming language, and the basics of the 3 different workspaces, so 2D, Control, and 3D. But there was a lot that I did not cover. I didn't want to kind of give you information overload. But if you kind of want to do your own research into different Godot aspects, I'd recommend looking into any one of these topics. So like shader programming, the world environment node, which is kind of for like making scenes pretty, light nodes, animation trees, that's for like state machines, tile maps, audio buses, materials, particle systems, all the other different types of physics nodes, optimizing your game, exporting your game, and add-ons. But there's even more than this. There is a lot in Godot, and that's what makes it such a good like game engine, because any type of game you want to make, you can make, which is amazing. Finding resources for learning Godot engine used to be kind of hard, especially when it was in its early days, but now that more people use it, especially after the Unity incident, it's easier than ever to find Godot resources. In my opinion, one of the best resources is the Godot documentation. It's great for not just learning Godot, but just kind of using it past the learning stage. I still use it whenever I just like forget something. I forget like how a method works or like what variables a node has. So I definitely recommend taking a gander at the Godot documentation. But there are also many other valuable YouTube channels, forums, and websites for learning Godot's many different things. And here I have this QR code, which kind of has a directory that I made of some of my favorite and my most used Godot resources. So, do I have the link here? I do not. Shoot. Or wait, no, I had it. I did have it. It's over here. There we go. Yeah, so I kind of have a big list of a lot of different resources that I found useful. Here's a kind of my favorite articles of the Godot documentation. These are ones that they either kind of help out for like people starting, or they kind of just have good information about like GScript and just stuff that might be easy to forget. Some articles and websites that I use, like different blogs and stuff like that, or like reference websites. I especially recommend Kids Can Code. I love these people that make really good Godot tutorials, especially for like kind of small idiosyncrasies it has, like 3D rotation. This is my holy grail when working in 3D because it can be a little bit tricky sometimes. So here's some YouTube channels. They make like some good tutorials for not only making different types of games, but different aspects of the engine itself. Some forums. This is always good if you just have like random specific questions. So there's a Godot forum. I think Stack Overflow has its own little page on it. The Reddit. And the GitHub issues. This is good if you just have like one weird random problem. And then lastly, over here, I have some kind of extra resources for not just Godot, but for making games in general. So here are some of my favorite add-ons, along with a link to the Godot asset library. Some of my favorites are like Dialogic 2. I love this one. This is for making like visual novel style dialogue boxes. Or like H-Train if you want like you want to make like bumpy maps. That sounds bad. If you want to make like terrain, like natural terrain. I've also heard good things about Panku console. This is like a default, not default, a debug console. And lastly, here's a list of some assets, some places where you can find some good assets, like Godot shaders. I love this one. This has a lot of like some shader code that other people have made specifically for Godot. But if you want to reference other different shaders too, there's Shader Toy. It uses a different programming language, different shader language than the one Godot uses, but Godot Docs actually has a guide for converting these shaders into Godot shader language, so that is very nice. Open Game Art, I love this one too. This has a lot of like no or limited copyright 3D and 2D assets. And also a few more like Polyhaven, no copyright 3D stuff. Free Sound for sound, Mixamo, this is for 3D animations. Kenny.nl has some free particle billboards. And also you can check Itch and TurboSquid. They don't all have free assets, but they do have some. So I would recommend checking those out. So here's a QR code if you want to check that. If you want to like see this list, check out the links yourself. And that should be all. So thank you so much for viewing this workshop. Took a lot of work to make, but I hope that it kind of teaches you how to use Godot. And I wish you luck in making your own game in Godot. So have a good one.